So hello everyone, welcome to this new series. Myself Achintya Singh from 21 Coders, and I'm recording this video third time. I first time I forgot to start the recording, second time I forgot to add mic, and this is the third time I am doing. Hope this is gonna be success. Okay, so why unfiltered? Why the name unfiltered? And this is unfiltration of concepts basically, and this is unfiltration of how I learn my concepts, and I want to know whether this way of learning works or not. So that's why it's unfiltered. I'm not gonna do much of editings in these videos. It's gonna be raw raw videos. There are not gonna be much cuts involved in this video. And let's start with the first topic of today, which is gonna be zero knowledge. Now the format of this particular series, how I'm gonna take it is of, you know, my learning method is that first I understand all the basics of that particular concept, and after understanding all the basics it's easier for me to understand the mathematics running behind it. And because I love maths, so I definitely want to go behind the mathematics of all these concepts. Now what happens is, when you understand all these things mathematically, it's really easy for us to apply it practically, and that is the whole and sole reason why I'm going to follow this particular methodology. And that is the whole and sole reason I call it unfiltered of concepts. Let's start with today's first concept, which is zero knowledge. Zero knowledge is heard by a lot of you outside there who is maybe seeing the video, who is not. A lot of people have heard about this particular concept, and it's trending method in blockchain ecosystem or blockchain technology, right? Many protocols out there are using this particular technology, using this particular algorithm in order to make new applications out there. What is zero knowledge? I know already that you know zero knowledge. You, by the words itself, anyone can say zero knowledge, right? But there are a few concepts, believe me, inside this which are gonna be new for you, which is the pillar of zero knowledge. But for this video it's going to be theoretic. In the next video I'm going to bring the maths behind this. What are the equations, what are some algorithms involved in zero knowledge? Let's start with zero knowledge. Okay, so zero knowledge, accordingly, the way I learned, the resources I used, I found out that it is nothing but a cryptographic method in order to prove something to someone. Okay, now this proving someone and proving to someone is involving two parties. There are two parties involved in it. Let's call it party 1 and party 2, and I want to explain you this by an example which I used to understand. Just imagine that I'm on an airport. I'm just gonna take the entry towards the airport. There is an officer who is gonna verify me by some of my identification proof. It can be like Aadhaar card, it can be passport or anything out there which I have, and I need to show it in order to enter airport, right? But there is a layer in between which is able to see my secrets. It's able to see my documents, right? And this can be a threat to me. I don't know whether it can be a threat or not, but if that particular verifier decides that I want to leak his information, he can very easily, right? So this is where zero knowledge comes in place and tries to solve this problem of not leaking the information and securing it, okay? But also solving the purpose of proving that yes, I am a legit person and I don't carry any security threat to your airport, right? So these two, prover and the verifier, these two have to do a particular work. What is that? The prover is basically here to prove to the party 2 that I know a particular statement is true. In this case, the statement is that I am not a security threat to your airport. I am an Indian citizen. Okay, this is the statement I need to prove. Okay, secondly, I don't need to reveal any information. The prover doesn't need to reveal any information. And what is the work of the verifier? If you see here diagrammatically, you understand the works, the things that these two guys need to do. Okay, so the party one is basically going to do the work of proving anyhow. He needs to prove anyhow that the statement is true without revealing any information. Okay, there is no information revealed, and the work of party 2 is in order to accept or reject it. So he has to either accept or reject. He can't be in a situation where he doesn't understand what is the proof about, what is the statement, nothing like that. Okay, moving on, how they are going to do this, let me show you with an real-time example. Okay, for example, imagine you are standing here and here is the verifier, prover and verifier. Prover says that, see man, I know the password and I can open this gate, I can pass through it. Verifier says, prove me how, by solving this challenge. What is the challenge given by the verifier? He says, pass this gate and prove me that you know the password. You know the password of this gate. This challenge has to be done by the prover now in order to prove him, right? And how he does that is he unlocks the door because he knows the password. Maybe it can be a fingerprint password, maybe it can be a 4-digit or 6-digit pin, whatever, right? But he opens the door, he passed through the gate, and now he says that, okay, listen, I know the password and that's why I am able to pass through the gate. In this way, he is not telling the password to verifier, okay? And the verifier is also has to believe it because he passed through the gate, right? And the whole challenge that the verifier gave is solved, and hence it is proved and approved. Okay, so from the prover perspective it's proved, from the verifier perspective it's approved. Moving on to the three main properties which I was talking about at the beginning of this video, which out of that one everyone has heard about it, zero knowledge. But what are these two? These were the new things for me which I was surprised. And why I was surprised, I'll tell you, because there were reasons. First one was why these two properties are required, which we will again be seeing below. Okay, let me just come to my way of how I started it. I approached it in a way, what is completeness first of all? So completeness is basically saying that if a statement is true and both parties are honest, okay, there are these two main points which you need to consider. First is the statement is true, okay, and both parties are going to be honest. No one is going to be like a cheater. If, for example, how I assume this is that if there is a human interference in between, there can be something like one party can bribe another, right? And maybe he can pass the door. But in this case, it's not possible because both parties have to be honest. This is made sure by this property, completeness. Okay, so if a statement is true and both parties are honest, the verifier will always accept the proof. Okay, this means that the work of the verifier has to be done 100% in order to make sure the protocol doesn't gets stuck. Okay, so he has to accept the proof. At some places I even read that in order to complete the protocol, it means that it shouldn't be in a race condition where a prover is not able to prove that the statement is true and the verifier is not able to approve him or reject him, right? So this is where a stucking condition can come in between, for which completeness property makes sure that no, the protocol is completed by either accepting it or rejecting it. Okay, second property, soundness, which is only for this making sure that the security of the whole protocol is maintained and there is no false, no cheating, no fraudulent things happening in the protocol. Okay, which says that if a statement is false, no cheating prover can convince the verifier. Okay, these are standard lines. That's why I have written it as it is. I have just copy pasted it because these are standard. So if you are explaining someone what is completeness, just say this line, which will basically show that okay, you know the concept. Inside that, what is there, what the breakdown, I have done it below, I'll show you. So soundness basically makes sure that if a statement is false by anyhow, the verifier is not gonna approve the prover. Okay, this is what soundness makes sure, except there is an exception. Because these all things are going to happen mathematically, there is still a negligible probability that it can pass. Okay, I'll show you how. When we talk about negligence, most of you would have heard about a topic called limits in calculus part of mathematics. In that, it is said that a number, a variable is tending to a particular constant. It can be 0, it can be 1, it can be anything. So when it is tending to 0, it doesn't mean that x is equal to 0. Okay, this is not equal to this, and this is not equal to x equal to 1. No, it is tending to 0, and the graph that forms is something like this. So the line is approaching towards x-axis, this line is approaching towards y-axis, but they have not touched the axis, and which makes sure that they are not equal, but they are just tending towards it. Similarly, here there is a negligible probability, which means you can't say that it can be like the negligence. If there is a negligible probability, it means it can be passed. No, it is similar to this. It is similar to this concept. This doesn't mean it is equal to 0. This doesn't means that it can, fake it. Okay, this is how it makes sure the security is maintained. And third thing, zero knowledge, which makes sure your privacy is maintained. So this makes sure it is secure, this makes sure your privacy, and this makes sure completeness. And this is why these three main pillars have to be there in ZK. Moving on, still I was not very much convinced by completeness, soundness, and zero knowledge, which was the reason I moved even forward to understand what is completeness. Again, in second language, what I got was that if the prover actually knows the secret or the truth, verifier will always accept it. He can't be in a loop, he can't be stuck at any condition, he can't reject it. He has to accept. Okay, only if the prover was able to prove him by solving the challenge. Okay, see, all in all, there is a challenge that is going to be given by the verifier, and if the prover solves it, it means that the statement is true. Okay, and he will always accept it. This particular thing has to be completeness has to make sure that this happens. Okay, moving on, soundness has to make sure that there is no malicious prover who doesn't knows the secret. He can't fool the protocol, he can't fool the verifier in any way. Okay, this is what soundness is gonna make sure. Okay, the probability of verifier passing this is negligible. Okay, again, we are not saying it's 0, but it's negligible. So mathematically, this is a way of speaking actually, but this doesn't mean that is being negligible it can pass it. No. Okay, it's again similar to that concept which I showed you above. Okay, let me give you an example which will again convince you why I am saying that negligible but still not possible. If there is a pin of 20 digit, okay, just imagine there is a pin of 20 digit and you don't know that. Okay, what are you going to try to do? You're going to try to guess it. Okay, but the probability of you guessing is so low. It is only 1 out of 10 to the power 20 outcomes. So there are 10 to the 20 power outcomes possible, which is a very big number, and out of that there is only one correct answer. So just see the amount of hard work, just see the amount of guesses that you need to make in order to crack this, right? And this is how we make sure that this negligence is also not able to be like break the security. And the third thing is zero knowledge, which is like simulation is done. When I saw simulation word, I was a bit convinced that okay, due to a simulation or a game or a challenge that verifier gives to the prover, it is very much made sure that there is no info revealed. Okay, and this is how these three pillars make sure that protocol is running, protocol is safe, and your data is also secure. And again, so taking out everything that we learned above, there are three importance. There is importance of each of them. Completeness makes sure that the protocol works, soundness makes sure that security is maintained, and ZK makes sure your privacy is maintained. So these are the importance when we come out of all those concepts. What if there is no completeness, no soundness, and no ZK? What if? Okay, this was the question which came in my mind, and I again did some research, and this is what I got. If there is no completeness, the maybe some of the honest provers also might get rejected. Okay, so completeness makes sure that this such conditions don't happen. Okay, soundness makes sure that anyone could not fake that there was a fake proof and he was able to pass it. This is what soundness makes sure. And if there was no soundness, this was the possibility that could happen, where like anyone can create fake proofs and they can break the protocol, right? This is what soundness makes sure. And if there is no zk, then there is no zk, there is no zero knowledge protocol itself, right? The whole and sole purpose of zk is to protect your data in order to protect your secrets leaking while verification, which is happening in the traditional way. Okay, now we learned everything. We learned all the three properties. We now know what is zk, everything. Okay, but still there are some small misconception which might happen when you learned above all these three properties. Okay, and what are those misconception? I have written that below, I have listed it below. So basically it is said that in zk, it's not the verifier, it's not that verifier is learning nothing. No, it's not that the verifier doesn't knows anything. Okay, in the zk property of it, it only knows a single thing. That's why I mentioned everywhere in a bracket except that the statement is true. Okay, it learns one thing, which is this, that the statement is true. This is the learning. Okay, secondly, soundness doesn't means it is impossible to teach. Okay, it is very important to highlight this thing. Why? Because in the next video I'm going to show you mathematically, and that is the reason I'm trying to make sure that I speak this out, that it's not impossible to cheat it. It's just that it is very negligible, which in this case, if you see cryptographically and mathematically in the next video, it's really very small. Okay, and for that small example which I gave you, that out of 10 to the power 20 outcomes, it's only one possibility that you can crack it, which is like impossible, right? Like impossible. Again, it's not impossible, it's like impossible. And third thing is that completeness doesn't talks about any size of the proof. See, completeness means that you have to complete, the verifier has to accept or reject it, but it doesn't means that it's completeness is not showing you that what can be the size of the proof that is generated. Okay, and with this I was able to understand properly what is zero knowledge, what are the three pillars, what are the three properties of zero knowledge. And now I am ready to move on to the next step, which is learning this mathematically. What are the mathematics equations involved in this and everything mathematically. And then we'll be going on to the third phase, which is the practical phase. And with this, I solved my purpose of learning ZK. Let me know if you liked this breakdown of how I'm approaching a particular concept, which is why I'm calling it unfiltered. And let me know in true terms if this is what unfiltered is. Okay. Thanks for watching this video. If I'm missing out anything in between, please let me know, because I'm open to learn new things. Even I'm learning this, so there might be a possibility that I would have missed out something which was important. So let me know. The resources of mostly all the blockchain concepts are very, unplaced. You have to search a lot of websites. You have to search a lot of resources. So mostly I refer to the white papers that have been written for these concepts. But they are so hard that it's not possible. In order to understand everything from a single white paper, you have to do research of resources outside as well. Like all the mathematics involved in the zk is like you can't understand in the white paper which is there. You have to first take a reference of those mathematics, those algorithms outside. You have to learn them, and then you can come to the white paper and understand what new innovation has been done using these equations and using these algorithms. So thanks for watching this video. Hope you liked the video. Make sure maybe you like or subscribe this, so that the next part, the mathematical part, when I release it, it's on your notifications. Thank you. Keep coding.